There will be times that we may need smaller numbers than obviously a float or a double. Well, Java allows us to also differentiate those. So it's very interesting how all of this works in Java, right? So it's strongly typed language, meaning everything has to be declared, meaning the types have to be declared to our variables. So you can't just put, for instance, this amount of number inside of an integer, right? You can put integers into a long, right? This number can go in here, but the other way around doesn't work. So everything is specified and we have to follow those rules. Otherwise, we get into compile errors. So the next number per se that we can use if we want to go smaller is what we call a byte. So a byte, if you say byte like that, that's the keyword, is the smallest type of number, right? In this sense here. So I'm going to actually take this byte and put at the top here. I think it's better because it's a number, okay? So I say a byte. I'm going to say, give it a name B, and I'm going to give it, for instance, 1. So that works. But the cool thing about a byte is there is a threshold, right? The byte can only hold up to 127, okay? The largest number that it can hold, the capacity is 127. Let's see, if I say 128 like that, notice we have a problem. It says required byte found int. So the moment we put 128, it's going to be considered an integer. So if I put 127, you notice that we have no problem, right? So I'm going to say 127 is the max. Now this could be minus 127 and plus, in this case, 127. So it goes from minus 127 to plus 127. That is the range for a byte. Okay? So if you want something smaller and is confined, then you will use a byte. Very good. Now, the other one we can look at is called short. So if we want something bigger than a byte, but not as large as an integer, of course. So a short, it was going to be twice the byte. You see the recurring theme here. So if I say short, and again, these are all keywords. We did not create these. These come with Java. I can say S, for instance, is equal to 156. Notice that it works because we said short is twice the size of the capacity. So 2x byte, like that. So it's twice as bigger as the byte. All right. Now, if I were to say 400, something like this, there we go. So now we've learned int, long, byte, and short. Now, the main question is, when do I use these differentiation of numbers there? It all depends on what you're doing. And of course, this becomes more apparent when you start learning more about Java and start understanding how to build applications, how to build projects using Java. And for now, this may seem very strange as to why is it so important. But the reason why is because it's easier to differentiate different buckets so that we don't overuse things, right? It makes no sense to ask for a bucket this big to put a number, say, this big. It's just a waste of space, right? So remember, in computers, we are trying to always minimize the footprint, meaning we're minimizing memory, even though in the last years, memory hasn't been a big problem. But when we are programming, we need to minimize the footprint of our code, of our project, of the footprint of our code, right? Which leads into good efficiency, right? So writing efficient code is one of the most important things you can ever do. So this helps with that efficiency. So think of use what you need only in a programming. So that will help with the efficiency as you program. Okay? Very good. So we have short, byte, long, and int. Now the next part we learn about the string. Now there is also a subset of strings. So meaning a string, you can put any text that you want here, anything. You can keep going until you can't even type anymore, okay? That's the beauty here. The string can keep going and going and going. But there are times that we want to deal with smaller subset of a string. Yes, in Java we have such thing as well. So if you want a smaller subset of a string, that's when you use a char. What is a char? Well, char stands for character. So if I say char like that and say A, that means I can only add one character. Now, what is a character in Java or in programming? A character is anything that only has one item in it, right? So this G would be a character. If I say something like this, you notice that I may have problem. Now, what is the problem here? Well, incompatible types. It says required char found java.lang.string. So that java.lang.string is indeed a package, right? Where we find the string library. So what it's saying here is that, well, okay, you said this type is a char, which means a character, so one thing, yet you put two things here, or more than one thing. Now you may say, well, okay, that's not true because I didn't put anything inside of these double quotes. Well, the compiler sees this as a string. Why? Even though it's empty, we should say, well, there's nothing there, so it should be just one item. Well, the compiler, like I said, sees it as a string because we put it in double quotes. There's a difference. If we want to start adding something to our char or character, we have to put single quotes. Then it knows exactly we're talking about a character. Now, this is a problem. It says empty character literal. That means we have to actually put something. So if you say A, now it's going to say the character A contains A, which is true. If you come down here and say A, you're going to see there is name is A because we said the character holds A. I can say for because it's inside of single quotes. This will be read as a character. So anything inside of quotes was going to either be read as a string if it's double quote or as a character if it's just one single quote. This is not an integer, even though it is an integer if you look at it, right? If we were to run this, it will look as 4. There's 4, but programmatically speaking, it is a character. So I can't say A plus 5. I should have an error because it's going to say, well, you can't add a character with an actual integer. You can concatenate them, which we were doing here. We are gluing things together. Again, this is not addition. We're not adding it, which we'll talk about later. So we are concatenating, we are gluing things together, but you cannot add those because those are two different types. So types are very, very important in Java. Very much so. So that is one thing that if you're coming from a different language where types are a little bit more relaxed, Java can be a little bit tricky at first because there is a very rigid sense of belonging, meaning that types are very rigorous. All right, there we go. So of course, anything you put here, even a dot, is a character. Exclamation mark, anything you put inside here will be considered a character. Notice it has to be only one thing. If I try to put something like that, then this becomes a string. It says too many characters in a character literal, right? Because it say, well, this is too many, so it shouldn't work. And the beauty here is that because we have this wonderful IDE, it even helps us say, okay, do you want to fix this? You can click here, it says convert to string literal, which makes sense, right? Because if you have more than one character, that would be a string. So the compiler is helping us to solve this issue by say convert to string. But we know that we don't want to convert anything because we just want it to be a character as such. Very good. There we go. I'll see you next.